right, now it's recording. Okay, we got it. Okay. All right, so we're going to go over the test questions and try to explain some of the best choices. It says each box contains 6 pencils as shown in the table. 1 box is 6, 2 to 12, 3 boxes 18, and 4 is 24. It says which list includes only the independent quantities. Well, independent quantities are X. X is always the independent, so it would be the 1, 2, 3, and 4, and it has to be choice A. These are all the X's, these are all the Y's. Independent is X. For number 2, it says the cost, let me put this on top. It says the cost to attend a school dance is $3 for each student. That means for every one student, they're gonna pay $3. Which statement is true? Now, in this instance, remember, it's what you do to X to get Y, so it should always be a Y equals statement. If each student is $3, then your total cost is gonna equal $3 for every student that comes, so Y equals 3X, or $3 for every student that goes. So it's not gonna be X equals Y plus 3. It cannot be X equals 3 times Y, because your $3 is going to be multiplied by X, not Y. It cannot be C, it must be D. Y equals 3X, because every student at the dance, for every one student, the amount of money earned increases by $3. So that fits what we have, the Y equals $3. All right, let's look at the next one. Number 3. Ooh, I'm too far up. Okay, it says the total cost of the snow cones T depends, so that's your Y, that's your dependent variable, depends on the number of snow cones ordered, S. The relationship is shown in the table. So 2 snow cones cost $6, which if that's the case, then 1 is going to cost $3. Do you see that? It says which equation can be used to calculate the total cost of the snow cones? Well, that should be easy, because the total is going to equal the number of snow cones plus the cost of each, which would be $3. So if I look at that, the total is going to equal, not plus, it's multiplied by. For every 1 snow cone, you could charge $3. So you would multiply the number of snow cones times the price for 1. So that would be 3 times whatever the snow cones are. So 3 times X equals Y. Or 3 times the number of snow cones equals the total. So it's going to be the total equals 3 times X. Total equals 2 times X. That's the same thing if it were an X. Total equals, no, it's not 2 times S, it's 3 times S. I'm messing up. Total equals $3 for every 1 snow cone. So you're going to take $3 times the number of snow cones, and it has to be B. You would not be adding, you would not be multiplying by 2, because the connection here for all these is going to be times 3, times 3, times 3. So the rule has got to be Y equals 3 times X. All right, let's look at the connection on the next one, number 4. It says which rule best describes the table below? Well, if you look at what we have 4 to 9. There's no regular pattern there except for maybe 4 plus 5 is 9. 7 plus 5 is 12, 9 plus 5 is 14, 10 plus 5 is 15. So it looks like that your B equals whatever A is plus 5. So let's look. It's not going to be plus 1, not going to be plus 2. It's got to be plus 5. Hopefully you got that one right, because it wasn't that complicated with the relationship, and pretty easy to see the connection in the field. Okay, it says with his fins on, Sam can swim at a rate of 4.5 miles per 1 hour. Which table shows the relationship? So 4.5 miles for every 1 hour. This is just like a regular rate problem. only I noticed that we have the distance in miles, but the time is in minutes. Remember, 60 minutes equals 1 hour. So in 60 minutes, it should be 4.5 miles. So if we look at what we have, I have 10, 20, 30. I could double the 30 to get 60. If I went from 30 to 60, that would be 6 miles, which is too many, so it can't be that one. Same thing here, 30 to 60. 30 times 2 is 60. 2 times 2, that would be 4 miles, so it can't be that. Oh, I don't have a 60 here, but I could go from 20 minutes to 60 minutes. So if I had 60 minutes, 20 times 3 is 60. So 1.5 times 3 is 4.5. I'm almost sure that is. 1.5 times 3 equals, yep, 4.5. So there it is right there. And let's double check and make, this one, C is the yes. That's the big fat yes. Oh, and it cannot be this one because it's the same as the top where you got 3 to 60, so that would not be nearly enough. So the answer choice is C. 4.5 miles in 60 minutes is equal to the table of 1.5 to 20, 3 to 40, and 6 to 80. And it's all about the minutes. You got to have it in the same units so you can compare them. All right, Ms. Park is using the following equation to predict a student's final exam score using F. Now, the final score is like the total, or what the X is. I mean, what the Y is. So the total equals, F equals 0.73 times G plus 16.8. It says, what is the dependent variable? The dependent variable is going to be what the total final score is. So that's going to be your F. The student's final exam score is going to be the variable because what you do to X determines what Y is, and that is the rate times whatever the G would represent, the grade, plus the 16.8. So F is going to depend on what you do to this. So F, the final exam score, is the student's dependent variable. This is not very good. The table shows how many toys Claire owns and how many she will donate to charity. So if she owns 12, she's going to donate 4. If she owns 9, she's going to donate 3. If she owns 6, she's going to donate 2. So if we look at how this is connected, 4 goes into 12 3 times. 3 goes into 9 3 times. 2 goes into 2 goes into 6 3 times. So the value of X divided by 3 equals the Y. So we want to look at how many she will donate. So our Y is going to equal whatever X is divided by 3. So 12 divided by 3 gives us that. 9 divided by 3. So it's got to be Y equals X divided by 3. All right, let's look at the next one. Susan questions several dozen people to find out their height and shoe size. She's planning on using data to develop an equation that will predict a person's shoe size based on their height. So the shoe size is going to be determined by their height. What would the independent variable be? So if their shoe size is determined by how tall they are, the height would be the independent, and the shoe size will depend on how tall they are. So the height is going to be, Susan questioned several dozen people to find out their height and shoe size. She's planning on using data to develop an equation that will predict a person's shoe size based on their height. So the shoe size equals whatever they're going to do to the height. So it would be, what would the independent variable be? The independent variable would have to be the height because you're trying to get the shoe size. That's what everything needs to equal, so that's your dependent. The shoe size depends on the height. Shoe size depends on the height. All right. Let's look at the next one. Number 9, it says a $50 deposit is required to rent a tool. The tool can be rented for any number of hours at a cost of $25 per hour. The total cost, T, can be calculated using the equation given below. Select the dependent variable in the given situation. Okay, so T is the total cost because you're gonna have the rate of 25 per hour plus the $50 deposit. So this is what you do to X to get Y. So T is the dependent variable. The T depends on how many hours you rent the tool for. All right, let's look at number 10. 2 students, Blake and Kyle, have summer jobs. The table shows how many hours Blake works and how much money he earns. Kyle earns $2 more per hour than Blake does. So these are Blake's hours. It says which equation represents Kyle's earnings in relationship to the number of hours he works, and how much does Kyle earn after working 12 hours. So we look at this. The table shows Blake's hours. So if we know what Blake makes per hour, we can calculate that rate by taking the 37.50 divided by 3. 37.50 divided by 3. That means he's making $12.50 for 1 hour. So 1 hour would be $12.50. Kyle earns $2 more than Blake. So for Kyle, 1 hour is going to equal $14.50. Is that correct? And let's see, which equation represents Kyle's earnings in relation to the number of hours he works? How much does he make after working 12 hours? Well, it's going to be $14.50 times 12. $14.50 times 12 hours, I would think. Clear. $14.50 times 12 hours equals $174. There is your equation that we just did. There's your answer. So there it is. You're going to take the rate of $14.50 times the number of hours, and that gives us the $174. Okay, this is a graphing. It says the graph shows the amount that Becky charges for different numbers of babysitting hours. So here's the number of hours. How much she works determines how much money she makes. Which equation represents the charges for Y? The charges Y for X number of hours. So let's look at what the rate is. For every 1 hour, she makes $4. 2 hours is $8. $3 is $12. So she's actually getting $4 for every 1 hour. That is the rate. So if we look at this, the total amount, or her Y, is going to equal whatever the rate of, whatever the number of hours is times the rate. So $4 times the hours. And if we look at that, that's going to be $4 times the X, which is the number of hours. This is your X. This is your Y. So it has to be Y equals 4X. All right, number 12. Let's see what we get here. In the table, what is the relationship between the height of a rectangular prism and its volume? If the height increases, yet the length and width remain the same. Wait, let me read that again. In the table, what is the relationship between the height of a rectangular prism and its volume? If it increases, yet the length and the width remain the same. All right, that one's kind of confusing for me, but let's look at what we got. We want to find the relationship, so we got to find the connection between the values that we have here. So let's just start out by dividing and seeing what the connection is. So if I have 1080 divided by 10, of course that's going to be 108. If I have 1296 divided by 12, that's going to be 108. Okay, so I see a connection here. Let's see if it's the same for 1512. 1512 divided by 14. Let's see what the quick connection is. Okay, it is also 108. So we're looking at the 108 is the thing that they have in common here. So you've got the number of hours times 108 gives you the total volume. So volume equals, it can't be that one, 108 times the number of hours. Wouldn't be subtracting, wouldn't be adding, so it has to be B. So your volume, or this column, H, equals the rate of 108 times, that's not right, the volume equals, we're looking for the volume. The volume equals, that's the y equals whatever the value is in height times 108. So 108 times the height gives you the total value for that. It would not be the subtracting or the adding. It would have to be multiplying by the rate, because we divided to find that 108 common value. All right, let's look at number 13. It says a rental car company charges $30 a day plus a $50 initial fee. Which equation models the total cost for renting a car for D days? So $30 for each day, so 30 times the number of days plus the initial fee is $50, that's going to equal the total, or the y. So the y equals 30 times D plus 50. No, that you're not multiplying 50 times the days, you're multiplying the 30. That is your independent variable. This is your dependent variable. So C equals the $50 per day plus, $50 fee plus $30 per day. And that's the only one it could be. It looks like A and D are the same. Yeah, it's got to be B. Okay, number 14. A scientist is studying the effect of temperature on the growth of bacteria. The data collected is shown in the table below. What conclusion can be drawn from between the temperature and the bacteria? Well, let's see how it's connected. So what is 500 divided by 20? I'm just seeing what the connection is. So that's times 25. Let's see. 600. Oops. 600 divided by 25 is 24. Uh-oh. Wait a minute. 600 divided by 25 is 24. Uh-oh. Let's see. 700 divided by 30 is 23 1/3. Okay, so it looks like the higher the temperature, it's not the same. They're asking you to make a conclusion from that. It says the higher the temperature, higher temperatures result in faster growth. The bacteria grow at a decreasing rate. The temperature has no impact on bacteria. Growth rate is random. All right, so it looks like where you've got your temperatures here, the lower temperature gives you less bacteria. The higher temperature gives you more bacteria, so the higher temperature results in faster growth. Bacteria grow at a decreasing rate. No. The temperature has no impact on the bacteria. No. The growth rate is random. Well, not exactly, because it's kind of a steady decrease. So the higher the temperatures result in a faster growth. I really don't like this question. I think it's kind of a, it's not as much of a mathematical question as it is one of our science questions where we use independent and dependent. And this is not using the table or the graph like we had started, but anyway, that's your answers. That's all the correct answers. So if you really struggled on this, we probably need to do the Ed puzzles and try to get a better look at, everything.